The DNA in the human genome is made up of billions of what are called nucleotides. Your body uses specific sequences of them, called genes, to build the many different proteins crucial to life. If a gene is faulty, it presents the wrong instructions, and the protein made from it can be defective, and that can cause a genetic disorder. To heal such diseases, you therefore have to replace or repair faulty genes.
Rare genetic diseases collectively affect millions of patients worldwide. So these are they don't always have the same disease, but they all have like a genetic source of this disease that can potentially be treated with gene therapy or gene editing.
Altering a patient's DNA is no simple task. To treat genetic disorders, tailored viruses are often used. They're able to smuggle a correct version of the faulty gene into cells. Once inside the cells, molecular editing tools insert this correct code, replacing the patient's faulty DNA.
You can think of gene editing or gene therapy treatments like a microsurgery for your DNA. So even small changes in DNA can lead to huge effects. I think you can think about it analogous to language. So if you think about a sentence and you change like a single letter in that sentence, it can substantially change the meaning. And the same is true, for protein and DNA sequences.
For many gene therapy treatments, a patient's cells are removed and their DNA is edited outside the body, or ex vivo. The repaired cells are then returned to it. However, the gene editing components can also be injected directly into the patient, a process called in vivo gene therapy. Both have their own advantages.
The advantage of in vivo gene therapy can potentially be its simplicity. So the application can be logistically much simpler than with ex vivo therapies, where first cell-cloned patients have to be removed, then ex vivo manufactured, and then reinfused into the patient.
A groundbreaking in vivo gene therapy treatment helped infant KJ Muldoon, who has a rare condition that would have soon led to brain damage or even death. Researchers have also used the method to try to treat hundreds of other patients for previously untreatable disorders, from sickle cell to Parkinson's to certain kinds of cancer. The gene therapy revolution in medicine has begun.